I think we should just start. It's okay. Let's all open. Yeah. So people on this side, please open the D drive. I think I taught you last time how to do this. You have to go to local disk D and open your D drive. Okay. And people on this side, you have to open the E drive. So local disk E and then E drive. So yeah, local disk E. There's a folder called day3, and inside the folder there are two documents. One is a, okay, do you know what a PPT is and what a PDF is, the difference between them? Does anyone know? Do you know? Yeah, one is a PowerPoint presentation, it has slides and like you can slide through. A PDF can be any, yeah, any like any file or like anything. It can be pictures also, right? So I have like, so mostly when we're doing like presentations, it's easier to work with PPTs because you can just move on to the next slide, right? But I wanted to check if like, I wasn't sure if it would work on these laptops, so I downloaded both a PPT and a PDF. So whichever works for you, open that. Like I would prefer like a PPT, PPTX. Like you see the dot PPTX, right? That's a PPT. And a PDF is a dot PDF. Okay, so open whichever you can. Try the PPT first. If it opens, well and good. If it doesn't, then try the PDF. Sorry? It's working? Okay. PPT is working, no? Nice. So open the PPT. And if someone's facing problems, just raise your hand and I'll be there. Okay? This is not the PPT that you've downloaded. It's in day3. That one, ML workflow. Okay. So PPT. Are you facing any problem opening the PPT? It's not opening? You need a lot of patience to work with these. Search File Explorer. So your File Explorer has all the files that you need and all the files that you download. It's all in the File Explorer. Okay? Yeah. Just go to local disk E, niche. So niche, local disk E. Yeah, and now there'll be a day3. Yeah. And download the PPT first. So which one is a PPT? Can you tell? Look at the type. Yeah. So open this. Is logged for editing. Just open documents. Open. The first option, I think. I can't see what it is, but yeah. So your PPT is here. Okay, the graphics are really bad on this one, but day3. 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 Okay. Open it. Double click. Yeah. PPT. Which one's the PPT? No. See, like in the type, you see Microsoft Office PowerPoint presentation. Open. Okay. You got the PPT. Okay, yeah, nice. Everyone has the PPT. Now, do you have the PPT? Okay. Are you facing any problem? Go to day3. Oh, wait, leave it. So if you press too many times, it like you can change the name. Like when that happens, that's for you to change the name, but we don't want to do that, so we'll just press twice and so you don't have this one. You're just gonna have to open the PDF. Okay. PPT is your PPT. Okay, nice. Okay, so let's start. Okay, no chess unless you're playing with AI, right? Uh, so, oh my God. Yeah. Also, important announcement before we begin. So tomorrow you have a PTM, right? So how many of you are showing up to that PTM? None of you? You're not coming. So tomorrow I was thinking that we could like have your Gmail IDs in the laptops, but if you're not showing up, whoever's showing up can come. Okay? Yeah. Then next important thing is, okay, let's begin. Now you're probably wondering, oh my God, finally we'll get to the coding part today. But we have one more PPT to go through, just one last PPT to go through, and then we'll go to the coding part. Okay? So this PPT ML workflow. Okay, guys, no talking amongst yourselves. Is it important? Is it something? Is it like a problem you're facing? What are you guys doing on that laptop? Okay. Did that. So yeah, so today we're going to be learning about a project structure. How are we going to do things? How are we going to code, right? So this is your workflow, as in like what you'll be doing one by one. So if you go to the first slide, which is data collection, you'll see that the first step. Wait, this is batch one. Okay, yeah. First step is data collection. So when you're making, okay, what do you remember from last class? Mota mota, what do you remember? What did we do? Or like, do you, yeah, machine learning. Yeah, what is supervised learning? I forgot. Can you remind me? It's okay. Hindi, English, like I don't mind. Just yeah, machine. What is machine learning? Yeah. That's very nice. That's very nice. Supervised. Yeah. Oh my God. Yeah. Okay. Yeah. So anything about supervised learning? Supervised learning was the one where we had like labeled examples, right? And then there was this one like small little thing called linear regression, right? Where we plotted all the data points. Right here, we plotted all the data points and then we found the line of best fit to make predictions. Batch one today. Are you batch one? What's your name? Yeah, like I've never seen him too. It's okay. You did you sign up for this workshop? Um, yeah. I think you're in batch two. You can leave. It's okay. No. His name is not there. Okay. Yeah, so we did linear regression. So I'm really happy that you guys remember like some bits of it. And if you don't, you can just chat GPT, right? You can just chat GPT it really quickly and then tell me the answer. I won't mind. So linear regression. So we are going to use this algorithm today, or like the next few classes, to make. I also showed you a student performance prediction, and then I took a vote which project you want to make, and you chose student performance, right? So we're basically going to be making that today, uh, and we'll use this algorithm, linear regression, to make this student performance prediction. Right? Do you remember what like this app had? Like it had some features, like you had to type in like extracurricular activities, number of hours studied. Yeah. And then it basically outputted what your performance would be like in the next exams, right? So we're going, like, do you remember anything, or like you're like, what is this? You remember, right? Okay, so if you want me to go over anything again, just tell me, okay? Just tell me, or just tell ChatGPT, I won't mind, okay? Then today we're going to do this algorithm, right? So now we're learning about how a project really works, like what do you do when and how do you do it. So first we get our data. Obviously the first step is always, whenever you're doing a machine learning project, just get the data. And I also showed you a site last time which is very commonly used for data, Kaggle, very nice. Uh, okay, at the end of the presentation today, we also actually have like some spots for like whoever is the most interactive in class, or whoever does the assignments the fastest. That's like something for you at the end, but we'll come to that later. So Kaggle is the website that we use for getting data sets, right? So the first step is data collection. So the first step is getting all this data to our Jupyter Notebook or Google Collaboratory or whatever you're using. Like last time, we even opened a data set, right? We could see the first We did the import pandas as PD, right? Then we got our data set which had like rows and columns. We got that on our laptop, right? So that's the data collection bit. Moving on, the next part of the machine learning cycle is data pre-processing. So this is like just a very fancy way of saying that we look at what the data actually means. This is data pre-processing is actually the most important part of a project. Like right now, because you're learning, I told you that, oh, we're using linear regression, like I just told you. But in real life, you're going to have to figure out what you're going to use on your own, right? So here we look at our data, like we have our columns, then we look at what the values are, and then we try to see what the relationship between the variables, like the variables are the different fields in that data set, and we try to find out what the relationship between those variables is, so that we can use a suitable algorithm. For example, like I'll also like give you resources to help you know which algorithm to use when, but this is the most important part of machine learning. So for example, linear regression we mostly use when there's like a linear relationship between data. For example, if our number of rooms increases, our price will also increase, right? So all of they will increase proportionately. Do you remember doing this in maths a little bit? Like this equation y equals mx plus c, right? So whenever the data has this sort of a relationship, we use linear regression. Okay. Then there's also multiple linear regression. Multiple linear regression is when instead of like number of rooms, you have all these different variables. Hi, are you in batch one? You want to give your names? I don't think if you'll be able to catch up though. We've already covered a lot, so yeah, sorry. Yeah. So if we're also taking into account the location of that place. For example, houses are maybe expensive in like Delhi. Okay, maybe houses are expensive in Delhi, but they're not as expensive in say like Lucknow. Okay, so we're also taking into account instead of the number of rooms, we're also looking at location, right? So I can't draw the graph right now because it will be like three-dimensional. Like there'll be like one variable here for location, so it will be three-dimensional. So I can't draw it here, but the machine, it can visualize it on its own because it's very good at calculations, right? So we will be using multiple linear regression this time, right? So the second step is basically to find out what algorithm we have to use. Now these are very simple algorithms, but if you like learn more about it, you learn about logistic regression and like nearest neighbor algorithms, decision tree algorithms, all these like very interesting algorithms which are actually very accurate. And sometimes we even combine algorithms together to find something that's very accurate. And usually, like I was showing you last time, there are some competitions that Kaggle hosts, some competitions, and you even get cash prizes. So the people who win are the people who choose the right algorithms. Sometimes they use a mixture of those algorithms, so that's how you get the most accurate results. So data pre-processing is the most important part of machine learning. Also, to like do data processing, we need to use pandas. Pandas is, I think like you have a little bit of an idea what pandas is. I think you've worked with it before, right? Because when I was writing, like you knew it already. So what do you know about pandas? Like it's just a word. We just write it every time we start our code, right? But pandas, so basically Python is a very good language to work with because whatever we want to do, there are some people who have already like written some code in Python, and we can use their code every time we want to do something. So our coding becomes easier because we don't need to know like what's happening inside. We can just use pandas to like access data frames, work with data sets, right? But there's actually like a lot of code, like low level, like difficult code that someone else has written in this library that we're using. Okay, so this is Pandas is a library that someone else has made, like the developers have made to make things easier for us. For example, like if we use Pandas, we just need to do pd.read CSV. Like that's all we need to write, and we have our data set. But someone else has written like very complicated code about like what exactly will happen when we read CSV. And this is a very complex process, like getting a CSV file from like Jupyter Notebook and then showing it, right? So this is very complex, but we don't need to know what it is, right? And this property of like code is called data abstraction. You don't need to know about this, just a term if you hear it somewhere, it's helpful to know. So most of the code, like for example, a machine only understands 0 and 1, right? But we write in like English language, right? We write in language that we understand. So how does it get converted to there? We don't need to know all of that. We just need to know that there's this function dot read CSV and it does our work for us, right? So this is known as data abstraction, that you don't need to know what's going on inside, but you can just use the functions for whatever you want to do. Okay, so one very important skill in Python, or like in any coding language that you learn, if you want to become like a successful coder, you have to be able to know how to read documentation. So if you search up, can you go to another tab and search pandas documentation? Right, because there's so much code, right, in the world, like so many people are writing code and there's so much you can use, but how do you know like what exactly, how did I know that we had to do dot read underscore CSV? Because you know code is, wait, just open the file and then I'll continue. Are you able to like catch up, like am I going too fast? Okay, okay. Just search pandas documentation and try to open the first link. Hopefully like the first link will be the most accurate. Yeah. Yeah, so go down. Can you see? Can you scroll down? Try to go to the user guide. Go down. Okay, yeah. So you have it here. Go to the user guide, and basically this will tell you how to use that, what to use, how to write code. Yeah, so exactly this is what we want to look forward. Are you facing any problems? Just do. Got it. Now search pandas documentation. What happened? Is there an issue? Are you okay? Well, like, okay. So the internet isn't working. This means. So basically, what pandas documentation does is, I can just tell you, Priyanshi and Priyanshi and Priya, I can just like tell you what it means. So it will have all the rules for like how to write code. For example, like you're not expected to learn like all the lines of code. That will be impossible, right? Even I don't know any lines of code. Like I just have to look at the documentation and know what to write where. So it's like an open book exam. You can look at the book, but you have to know where the answer is and how to look for the answer, right? So all the code that even like the most successful software engineers, they don't memorize all the code because that will be impossible, right? They just know how to look for documentation and how to look for example, if you want to open a CSV file, you can always just search like how to open a CSV file using pandas, right? That will also work. But if you want to go through like all the things that pandas can do, just go through the documentation. It will teach you like how exactly to do what. For example, like you're making, for example, you were making that game, right? Slack game, right? Now do you know about like what every function can do? Because Scratch is pretty easy to understand, right? Scratch, like you just take the word and everything, and you just have to drag and drop, right? But for these languages, you have to write those words on your own. So how do you know what to write? So just go to the documentation. There you'll see a list of all the functions that Pandas has, and you can use any one of them, whichever you want. Okay, so I'm basically helping you do this on your own through an exercise, which we'll come to later. But just are you all on? Go back to the PPT, the second slide, which is data pre-processing, preparing the data for analysis and model training. This includes handling missing values. For example, if your data has a lot of missing values, then the model will not be accurate. So we also need a way to deal with that. But good for us, like Kaggle, most of the data sets on Kaggle, someone has already cleaned them for us. So it's good for learning. Okay, then normalizing standards, this will come to later. Then third is data visualization. So now this is also like kind of a part of data pre-processing only. We basically draw graphs to see what for example, we want to see the relationship between number of rooms and price. In our thing, we'll see the relationship between previous scores and current scores. Okay, we'll see the relationship between previous scores and current scores. So, uh, like if there's a linear relationship, then we'll use a linear regression. If it's not a linear relationship, if it's something like this or like something like this, then we'll use another algorithm. Yeah, polynomial regression, very nice. So then we'll use some other algorithm according to what the relationship looks like. Okay, then let's go to the next slide, which is data splitting. Okay, this is important. So now I told you there are two parts to a model. First, we train the model, right? And then we test if the model is working okay, if it's accurate, right? Because we can't just like train the model and then not know how accurate it is. We have to train the model first, then we test the model. Okay, so for this, the thing is, sometimes what machines do is if we feed it some data and that data maybe it's not an accurate representation of the world, maybe like it's not that accurate, right? So our model will only learn to predict like the data, right? It won't be able to predict anything outside the data. For example, if I have like some data points here and the model like it basically learns to predict values that are in the data set. For example, I have 5, 20, 10, right? I have values for only this. I don't have values for 0 to 5 or 20 to 30. So the model will only be able to predict values inside here. If there's a value from 0 to 5, it will not be able to predict it because it wasn't in the data. So sometimes it basically it takes the relationship between the variables and the training data too seriously. So it's not able to be effective in the real world when we use it for training. To prevent that, we divide our data set. Like, for example, we have a data set of like 1,000 rows, 1,000, like 100 rows, which is very small, it won't do anything, but there are 100 rows. 1, 2, 3, which means, for example, if you're doing a house price prediction, there'll be 100 houses and we'll have their prices. So we divide our data into like 80% training data, 80% for training, and 20% for testing. So in this way, when we train it on the data, we know the 20% testing is like left aside, so it's like new data. It's almost like new data. And when we test it on this 20% of data to see if it's actually accurate, so what we do is we ask it to predict, for example, the new data, we like take the information and we'll not input the label, which is like the answer, right? We won't input the answer. So then the model on its own, it will predict the answer for these values, and we'll see what the difference between these two is. So if the difference is very large, right, this is the actual answer that we have in our data set, but we're not telling the model. We're just asking it to predict. So it makes its prediction and we have the actual answer. So we subtract those two to see what the difference between them is, right? How good are they at actually predicting stuff, right? Because we need to know how good our model is or how bad our model is, right? Because then our predictions won't be right and we won't even know they're not right. So this is how, like, are you able to understand? I feel like I'm losing all of you. It's understandable, right? Actual answer minus predicted answer is equal to the error in our model, okay? Yeah. So yeah, for that, we have to divide our data set into 80% training and 20% testing, okay? That's splitting of data. Then finally, we come to the training part. So, okay, that's just what a training data set is or what a validation. So you don't have to know about validation data set right now. When we do more complex programs, then we'll do it. So look at the example. Okay, now imagine, go to the example slide. Example, yeah. So imagine you want to teach a child to recognize different types of fruits, right? You have 100 fruit pictures, which are the data points. So the training set will be, let's say, 70 pictures, and you will use these you will show these pictures to the child and tell them the names of the fruits. Then the child will learn from these 70 pictures what the fruits are. Then go to the training set, go to the third point. Then the test set, for example, is 15 pictures. Then once you think the child has learned enough, You show them these final 15 pictures and you try to see how well they can answer, how well they can identify, right? It's like teaching a child something new. That's what a model does, right? It's like teaching the computer something entirely new. So we need to have some training and some testing, okay, to know how well it does. For you, for example, you guys also, you have exams, right, to test what you've learned, which is just a small subset of questions from your entire syllabus. So that's what it is like. Then model selection and training, selecting the model and training the model. This part is actually the most straightforward. It's not like you just, so like I was saying, there's this library called Pandas. There's another library called sklearn. Okay, this has all the models for us. For example, if we want to use linear regression, we'll just do a new model equals linear regression, and then we will train our data using a new model dot fit. Like it's just 2 lines of code and your training data here in brackets. So it's just 2 lines of code and then you can train your model. It's very easy. So again, sklearn, this model is like doing a lot of stuff, but we don't need to know what it's doing. We can just use the model. Yeah. Okay. So you don't actually need to know what it's doing, like what the linear regression is doing. You can just use it. Like, right, new model equals linear regression. It's that easy. So someone else who's like made the sklearn library has already written all that complex code for you. So now you just need to write the name of the algorithm, and it's pretty easy. Okay, so it's not that hard. The biggest like part is identifying what algorithm to use and understanding the relationships between data. Okay. Then model testing. Again, like I was referring to, after you train the model, we test it on the training testing data to see how accurate it is. Then assessing the final model's performance on the test set to ensure it generalizes well to unseen data, right? So data that we don't know about. So now how do we test the model? Okay, last thing, how do we test the model? So for this kind of an algorithm where we, okay, do you remember the difference between regression and classification? Do you? Come on, I think you have the answer. It's okay. Just say it. Just say it. It can be wrong. It doesn't matter. You're doing this for the first time, so I understand if it's wrong. Do you have any idea? Okay, ChatGPT it. ChatGPT is the difference between regression and classification, and then and then tell me what it is. Yeah, yeah. Or you don't even have to ChatGPT. You can just Google, for that matter. If someone has like last time's PPT, it's also all there, regression and classification. And I've also, how many of you are in the WhatsApp group? Right, so the PPT is there. You can look at it. And what about the people who are not? Did you not get an invite? Oh, can you come to me after class? Can you stay back after class for 2 minutes and then I'll write down your numbers and yeah. Are you in the group? WhatsApp group? Okay. It's not working. Do you have yesterday's last time's PPT? I think it's still on your laptop. Go to day 2 folder if it's there. Look at this day 2. Yeah. Just open the folder because there are I think 2 documents in this. Just leave this. So, right, so introduction. It's all here. So has anyone? Yeah, that's an example. So it's like predicting a number, right? It's either 3 lakhs or 2 lakhs or whatever. And what is classification? Oh, you're using ChatGPT. Very nice. Yeah. Into groups. So cat, dog, right? cancerous or not cancerous. Yeah, very nice. So, what's your name? Sorry, Namrat. Okay. Yeah. So 3 lakhs. Like if we're outputting a number, that's regression. If we're outputting a class or a category, yeah, that's classification. Like cat or dog, or like any of these categories, then it's classification. So which one do you think this one is? Student performance prediction. Regression, right? Because we're outputting a number that, oh, you'll get 90%, you'll get 80%, right? So cat or dog, sorry, that's regression. So how do we test regression algorithms? How do we see if they're doing good? So for regression algorithms, this is our data, and we draw the line. Okay, do you guys have any idea what standard deviation is? Standard deviation. What is it? Like, what does it do? So standard deviation, for example, this is your y equals mx plus c. Like this is how your data is distributed. And you draw like a line to see, oh, like this is the line that best represents this data. So a standard deviation will measure the difference between these two. Like for example, how far apart the data is spread, right? So we usually do, for example, this is y, and the point on the line, like the point predicted by this line, for example, if I have x1, like a data point x1, okay, and then our equation of a line is y equals mx1 plus c. This is the y-intercept. This is, are you all understanding? Right. So using this line, our model will predict. Let's see this. This is how predictions are usually shown. So y and then a triangle on top. This is how we represent predictions made by a model. So our model will predict according to this line. It will predict this value, y hat. Okay, whatever lies on this line for this x1 data point. But our x1 data point actually had y value. So there's a difference, right? Are you able to understand? There's a difference. So we subtract this difference, like we try to see what the difference between these two is, like what is the difference, how far off was it? So we subtract these two, and then just to make sure that the points that are above and the points that are below are penalized in the same way, we basically square it so that the negative and positive, it's all like it all goes out. We square it and then we under root to like basically we've squared it. For example, okay, if you have -3, now I want to make it positive. Square it, but it'll become 9 under root. So it'll become 3 again, right? So that's why we're like trying to get like a positive value for our loss. And then if we sum all the losses, for example, this loss plus this loss plus this plus this plus this plus this, and then like take the average of all of those. So like summing all of these and taking the average of all of these, dividing by the total number, we get our error in the model. Now this is very complex. Again, you don't need to know what exactly it does. This is just so that you like understand better. But in like the actual thing, you just have to do like find root mean squared error. That's it. And then just one thing I want to explain. If your value is like the closer your value, for example, have you heard of this R square, like R square coefficient when you're doing statistics, right? Okay, so you're in 12th, so you've probably heard. So R square is, okay, just the last bit of maths, okay. So basically, if your R square value is closer to 1, if it's like 0.99999, sorry? Yeah, if it's closer to 1, it means that your model is very accurate, that it's like all of these data points are very close together. But if your R square value is like 0.67, it means it's only like 67% accurate. So it's not that accurate. This is all you need to know. If it's closer to 1, if it's 0.999, and all these values are between 0 and 1 only. So you have to see if it's like 0.999, it's very accurate. If it's 0.67, it's only 67% accurate. That's how we classify regression. So that's how we test regression models. Okay, I think if like I keep on going with the maths, I will lose all of you completely. So let's go to the coding. Sorry, you're a math student, okay? But for the rest of the people who might not be, right? So let's get to the coding part now. Can you all open Jupyter Notebook? And do you know how to save your project in Jupyter Notebook? Right, so we'll be doing that today so that you can continue from here in the next class. Does anyone remember how I taught them to drag and drop this file and then open that file? Like drag and drop studentperformance.csv and then open it? Yeah. Can it, for all those who remember, can you try to do it on your own? Otherwise, like I'll come to you and help you. That's not a problem. So everything that I told you, it'll all be in the PPT. So maybe once you go home, you can like go through that PPT and revise because I will ask questions the next day, right? So yeah, so can you open that? So for that, so I think it's already here. Like the PPT that you uploaded, it will already, sorry, not the PPT, the CSV file that you uploaded, it will be on Jupyter Notebook. You just have to call it, yeah. It's not installed in this. Can you share with these two or can you? It's not installed on any? How is that possible? But it's in also these three. There's no Anaconda. Can you check again? Can you search? Can you search Anaconda here again? ANA. So they're having trouble opening Jupyter Notebook.
I think yesterday our net problem was coming, no?
Yeah.
That is means restalled everything. So it can be due to that only. They can use this side or all that.
Okay, so is it working on those?
That only installing.
Okay, okay, okay. So it'll happen in some time. Okay, so either you can wait or you can sit on these laptops because they had to remove Anaconda from all these laptops. Sorry. Uh, is Anaconda working for the rest of you? Yeah, so you have to give the CSV file name here. A connection to the notebook server. Did you just open Jupyter Notebook without using Anaconda? Maybe that's why it's happening. Sorry? Yeah, no, no, no. You have to open Anaconda first, then open Jupyter Notebook from Anaconda. Can you search Anaconda and then there'll be a launch button. What is happening? Can you cross? Open Jupyter Notebook using Anaconda. Is it working on you guys? Yeah. You can start a new one, like this time. Yeah, this file is already there. Okay, okay, okay. Oh, no, no, you don't have to upload the PPT. Yeah, this CSV, which is already there. Yeah, so now open a new notebook. Go to the top. Upload. Yeah, sorry, new. Yeah, sorry. Yeah. Now, okay, I'll just help you with the code a little bit. So it's import pandas as PD and then data equals PD dot read underscore CSV and then your file name, which is student performance dot CSV.
That side also.
Okay. Okay, okay, okay. Thank you. Yeah. PD dot reads, yeah. Yeah, just copy the lines from the board. Oh, you can't see. Okay, I'll just tell you data. Next line, right? Data. Okay, can you open the Python documentation on another tab? Sorry, pandas documentation. Pandas documentation. Data equals PD dot read underscore underscore, no gap, no space, underscore CSV. Yeah, run it. Data dot head, it's HEAD. You've written CVS, it's CSV. So there's a problem with the internet, but can you look at this thing and then. Okay, before doing anything, where you see the file name as untitled, instead of that, just change it to your name, like your first, actually your name, and then underscore, what is it? Student, STUD underscore PER. Yeah. Import pandas as PD, data equals PD dot, so this is small, CSV is small. And this also, here it's small. How many of you can see the data? Before doing anything, just save it as like your first name underscore STUD underscore PER. Right? So that you can work on this file again when you. There's nothing inside the bracket. S is capital and P is capital. Yeah. P is capital. Dot CSV. Yeah. Uh, student. S is capital, P is capital. And P is capital. Data dot head. Or actually, sorry, just change the name to your name, and then underscore batch 1 underscore reg. Sorry, just change the name to this. Your name underscore batch 1 underscore reg. Okay, the name of the file. There should be no gap in between. So Priya underscore Rathor. Okay, just as a good practice, you should not leave a space in between your name, write an underscore. Because file names generally should not have spaces in between. Data equals pd dot read underscore csv student performance. Can you go down? Maybe the file isn't here. Uh, Go down. Now let's read the error. Okay, go down. Oh my God. No such file or directory. Go to the home page. So it's basically saying that you don't have the file here. So you'll have to upload button, this student performance. Click on it once and then open. Now try to go to, wait, sorry. It should show. It's not showing, which is, do you see a student performance anywhere? Yeah, done? Okay, nice. Can you help out anyone who's not able to do it? Okay, it's not here. It's not there on yours also? Let me try to. No, you can sit. File Explorer. Three, we'll go to, we'll go to this E, date 2. Okay, wait, it's loading. we'll have to call sir. Sir, can you help us? So we're trying to upload this file, but it's not happening. Okay, just no, no, no. Yeah, this one, student performance.
In this it is happening.
No, it's not happening on this either. Okay, for the rest, yeah. Also, this is the name of the file. This is not how you have to. What you have to write is sorry, file, rename. Here write Kanishpreet, whatever it was. Then copy the thing that's written on the board. So for the people who have their files, now, okay, now you have to see what the data has, like how many values it has, how large the data set is, right? So for that, there's a function called data.info. Run that, and then tell me what you see as the answer. Did it work out? Is it happening? Uh, can you try searching up Kaggle? Is it there? Oh. So are you able to import it in the, make another notebook? Go to the other notebook. Go to the home page and then make another notebook, new. Kaggle. Yes, sir. No, I'm trying to see if I can download it. You can see. Yeah. Data set. Kaggle. Yeah, I'll have to. Kaggle. Uh, I'll have to see. I'll have to check what the data set is. Yeah. So what did you get as data.info? Till then, can you share with data.info? What did you get? In what is the information? Can you tell me? Like, what can you see from the information? Did you do data.info? Nice. Okay. Yeah. What did you get as the? What did you understand from it? Yeah. What was it? Yeah. What are the data types? Can you tell me? No. Wait. Tell me the column name and then the data type. Are studied. Data type is int. 364 is, I think, 364 values. Oh, int 64. So these are different types of encodings. Okay, int 64 is it's a different type of encoding. 1 second. Okay, yeah. Data dot info. Yeah. So I think there are, okay, how many values are there for our study? 10,000, right? So there are 10,000 of each of these values. So we'll train our model on 10,000 data points. What else do you understand? Is there like, is there something other than int? Is it working? Okay, yeah. See, you can see it there, right? Just for now, just try to understand this from this pattern. Okay, what is the object? What is the object? Can you see? Priyanshi and Priya? Yeah, yeah, yeah. Can you guys see? Can you like pay attention here? What we're doing? What do you see? Extracurricular activities, right? What does that mean? It means that it's an object, which means it has values either yes or no. Right? That's a categorical value. So it's either yes or no. That's a class. Is there something funny? What are you guys laughing about? Okay, anyway. So extracurricular activities will either be a yes or a no. That's why it's an object, right? It's a class. Either it's yes or it's no. So anything other than, yeah, performance index is the final performance value. This is what we'll be predicting. This is the label of our data. Okay. This is the label of our data, and it's float because what is, okay, do you understand what float is? Decimals. Yeah, so float values are decimal values, and this is a decimal value. Everything other than that is an integer value. Okay, just want to check if, okay, now can you, is it possible for you to open pandas documentation side by side? Now, okay, now I want all of you to open pandas documentation and try to, maybe you've done this in class also, but you have to try to find out all the, okay, this is, I'm actually giving you a challenge, so I will not be like telling you how to, like what function it is, but you have to find out, uh, is any, okay, you have to find out all the null values. I don't know, maybe you can chat GPT, or you can look at the pandas documentation, or you can Google search, find a way to find out all the null values, yeah. Yeah, yeah, search in this and do it there, I don't mind. Just get me an answer. Sorry, not working? Acha, for to search pandas, search for pandas. Okay, then try to. Is that internet working? We're checking. This is a big problem. Okay, wait. So is your thing working? Have you been able to open Jupyter Notebook?
Open and closed.
No, you're not supposed to close it because we're going to be working on it. Okay, I think for this task, team up in two, like two groups of two, or like maybe you can, yeah, two, like two people. Find me a way to find all the null values in the data set, values that are zero. Okay, okay, okay. Jupyter's working here also, so it's the internet isn't working. Let me see. Let me find another laptop where it's working. And I'm so sorry, but like I wish there was something I could do to help like the internet issues. Either you can go through the documentation or you can even Google search. Like you can Google search as to. Uh, what was my question? How to find all the null values in a data set. You're very close, but I want a count. Okay, I want a count of this. You're very close, but that's good enough. Don't tell anyone. Okay. So is the networking here? Okay, if you know, I'll write out the main code for you. You start looking for how to like. Uh, 1 second. Yeah, it's so we'll do it. Don't worry.
Start. Click on start.
You have to log in as a.
Password. Where do you click?
Are you able to look at the data set? Okay, how many people have been able to find out a way to calculate this number of all the null values? Okay. Sorry. Yeah, try all the stuff that you find. You're very close. That's very good. Yeah. So yeah, now the internet isn't working. Can you open another tab? I can see Panda's documentation and it's open. Yeah, so now you can search how to find all the null values in a data set. Go search. Yeah. What are you facing a problem with? Okay, just try to search on another tab how to find all the null values in a data set. Okay. You don't have a Jupyter. Can you open Jupyter notebook? Second last. It's the, yes. What is this? Sorry, one second. Let me help you. Okay, now. Okay, one second. Can you? Um, oh, it's like how is there a new terminal running? Search for anaconda. Can you share with her? I'm so sorry. Uh, okay, so who found out the sum of all null values? Okay, let me tell you. It's okay. Try doing is null dot sum. Like some of you have done is null, right? Just add a dot sum after. You were able to? We can go on without sum. Very irritating. Yeah, your Jupyter notebook was working there, no? So maybe you can input this function there. Is null. I'll actually write it on the board. So you did is null. No, you don't need an internet connection. Just go. So df. It shouldn't be df. No, it should be the name of your data. What's the name of your data set? It's data, right? So data dot is null. Data dot is null. So were you able to do? Okay, data dot is null dot sum. What are you getting? Yeah, so all of them have zero null values, which means there are no null values. Can you do data dot is null? Go down. Okay, you can also do it in another cell, but because see, it will only output the last thing. Can you go over? Data dot is null. So yeah, it's saying these are all not null, but now you need to find the sum. So just do dot sum. Okay. So were you able to find out all the sum of the null values? Yeah. Yeah. You don't have to try running it. Uh, why are you doing this again? Okay. Uh, is dot sum in brackets? Why sum in brackets? Actually, can you just run this? Can you just run this code? Run, just run it. You don't need to print in Jupyter Notebook. The last thing automatic. Okay, okay, it's a variable, so print now. Run. You got it. Okay, you didn't even need to give it a variable name. The last, if you just wrote. अच्छा अच्छा ठीक है ठीक है. Okay, okay, so the lesson is over. I'm so sorry for all the network issues, but like there's nothing we can do about it, right? So if you want to leave, you can leave. Yeah, I mean it is time for you to leave, so you'll have to leave. Bye, 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 bye. Okay, bye, bye. Next time we'll actually work like make graphs out of this and then apply our algorithm. We'll finish it in next lesson. Sorry, coding. This is coding. This is coding, but next time we'll make graphs and next time we'll actually train the model. No, 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 no. We'll do like model. We'll make a model. We'll train our model and everything, but in next class. So right now, I was just trying to help you learn how to search for things. But next time, I'll give you the code and I'll do like you will all code and make the model on your own, and then we'll also test it. Okay? Yeah. Yeah. Is null. So dot is null. Okay. Do you want me to explain it to you? हाँ हाँ इसलिए तो मैंने बोला चैट जीपीटी या लाइक क्योंकि सारे कोड का मीनिंग तो 15 आवर्स में नहीं पता लगेगा. सो बेसिकली इज नल डॉट सम इज बेसिकली नल वैल्यू सारे ढूंढता है और फिर उनका सम निकाल देता है. राइट, डॉट सम उन सबका सम निकाल देता है. ठीक है, बट देखो अब मैं सारे कोड का मतलब नहीं बता सकती ना, तो इसलिए मैंने और भी रिसोर्सेज दे रही हूँ कि अगर कोड का मतलब ना समझ आए यू कैन सर्च बट यू कैन ऑलवेज आस्क मी. सो डेटा डॉट इज नल, बेसिकली दिस डेटा डॉट इज नल विल फाइंड आउट कहाँ पे नल है, कहाँ पे जीरो है वैल्यू. ठीक है, और फिर जहाँ पे भी वो जीरो होगी इट विल बेसिकली सम ऑल ऑफ दिस एंड लाइक डॉट सम will sum all the null values and then you'll get a sum of like oh यहाँ पे इतनी zero values हैं इतनी null values हैं. Are you able to get it? So what do you want me to tell you know, let you know? pd.read csv, did you understand? It's basically getting a csv file. CSV file is a comma separated value. So everything is separated in commas and basically it's very easy to convert that into a table. So that's why we do it. Okay guys, you can leave, you can leave. You can leave.